Okay, so we're on page 18 today in our notes packet, and we're going to talk about quadratic formula. So this is another strategy that we have to solve quadratic equations. So we've seen factoring, we've seen square roots, we've seen completing the square, we used graphs and tables. Now we're going to take a look at one more option that we have called quadratic formula. One thing I want to point out right at the very beginning, it's called quadratic formula. That means we can only use it with quadratics. So that's stuff where the degree is 2, polynomials that have a degree of 2, okay? Only works with quadratics. If you see an x cubed in there, you cannot use quadratic formula, okay? So we need our quadratic to be in standard form, which remember looks like this, everything on the same side set equal to 0, our x squared term, our x term, and our constant term. Quadratic formula uses the coefficients and constant terms from a standard form quadratic to be able to find our solution, okay? So here's what that looks like. Our solutions will be the opposite of whatever that b value is, plus or minus the square root of b squared minus 4 times a times c. This is all under our square root here. And then everything that I've written so far is then divided by 2a. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, whatever our b value is, we'll take the opposite sign. That's what that negative means. It means change the sign on b. Plus or minus in front of our square root. So we'll get 2 solutions, which should make sense for a quadratic. The degree is 2, so we would expect 2 solutions. And then all of this piece here is under our square root. And then all of this is divided by 2 times that a value. So we're just going to run through a couple examples of quadratic formula today. Okay, we're going to go through this together. So here's our first example. The first thing I need to do if I want to use quadratic formula, just like if I want to factor, is get everything on the same side set equal to 0. So that's my first step here. I've got this negative 14 on the other side. I need to move it over so that I have standard form. That gives me 2x squared minus 12x plus 14 equals 0. Now, if I were going to factor this, we might say, hey, there's a GCF of 2 here. We're not factoring. No GCFs. All I want is standard form, exactly like this. Okay, once you've got standard form, don't pull anything out. We're not grouping anything. I just need standard form. Once I have standard form, I like to identify my A, B, and C. For me, that makes it a little easier to plug these values into my formula. So my A is that coefficient for the x squared term. In this case, it's 2. My b is the coefficient for the x term. In this case, it's negative 12. Be careful with your signs. And my c is that constant term, the thing with no x. So that would be positive 14 here. Now I'm going to take the a, b, and c that I've identified and plug them into that formula that we wrote. Okay, that's quadratic formula. So I will have x equals, change the sign on my b value. So my b value is negative 12, change the sign to positive 12, plus or minus the square root of my b value squared minus 4 times a, which is 2, times c, which is 14. And then all of this is divided by 2 times a, which is 2. And now I'm going to simplify. Negative 12 squared is 144. So I'm just going to write these on top as we go through. And then I've got negative 4 times 2 times 14 that would be negative 112. So I've got 144 minus 112. And then on the bottom here, 2 times 2 is 4. I'm doing a little simplifying there. Remember, this piece is under my root. If I continue to sort of do my subtraction here, 144 minus 112 would be 32. So I'm going to write what I have left after doing my little tidy up. I've got x equals positive 12 plus or minus the square root of 32 all over 4. Now I want to simplify as much as I possibly can. I've got 4 on the bottom here. I know that 4 goes into 12, so I could reduce to 12. But what I want to know is, can I simplify this root and take 4 to reduce any of that? Okay, because I'm dividing both of these things by 4, I can't just reduce it with the 12 and call it a day. I also need to know if 4 reduces out of here. So I'm going to simplify my root. 32 doesn't have a nice square root, but I can still simplify it. So 32, I'm going to think of as 4 times 8. 8 is 4 times 2. If you factored this a different way, that's fine. You just may pull out a couple of 2s instead of a 4 like I'm going to. That's fine. And then I've got a pair of 4s here. So that means I could rewrite this as x equals 12 plus or minus 4 root 2, this guy stays under, all over 4. And now I can simplify that 4 out of both of these terms. So remember that we're looking at essentially this. I have addition on the top of a fraction like we have here. I can split it up into 2 separate fractions if that makes it a little easier. So 12 divided by 4 would be 3. Still have my plus or minus. And then I can reduce anything that's outside the root. We can't touch anything inside the root, but I can reduce anything outside the root. So those 4s will reduce outside the root, leaving me with just root 2. So there are my solutions, 3 plus or minus the square root of 2. So I have 3 plus root 2 and 3 minus root 2. So anytime we use quadratic formula, we need standard form for our quadratic. We need to identify our A, B, and C values, plug them in, and simplify. The bulk of the work here is the simplifying. Okay. We're going to run through some more problems together. Let's take a look at this next example. I already have standard form here, which is nice. Everything is on the same side that equal to 0. I don't have to move anything around. We can go straight to identifying our A, B, and C. So my A value here, since I don't see anything in front of x squared, that means that it's 1. Same for my B value. I don't see anything in front of x. That means that it's 1. And my C value is negative 4. Once I have my A, B, and C, I can plug them into quadratic formula. And I've got a quadratic formula we can kind of move around with us for today, just so we can see it. So now I'm going to plug in A, B, and C to quadratic formula. So x equals, change the sign on B. Since B is positive 1, I want negative 1, plus or minus the square root of 1 squared minus 4 times 1 times negative 4 all over 2 times 1. Now I'm going to go through and do some simplifying. I plugged in all my values. I'm going to do some simplifying. 1 squared under my root here is just 1. And then I have negative 4 times 1 times negative 4. That would be positive 16. So under my root, I have 1 plus 16, which is 17. And then on bottom here, 2 times 1 is just 2. So as I clean this up a little bit, I have x equals negative 1 plus or minus the square root of 17 all over 2. Now, in our last example, we looked at, could we reduce that bottom value with what we had on top? We've got -1, so I can't take 2 out of -1 evenly. I also can't reduce the square root of 17 anymore, so this is as simplified as this guy's going to get, okay? When you use quadratic formula, you can leave your answers in this exact form. Okay? There's no reason to give me a decimal for square root of 17. Give me that exact answer. Because as soon as you change something to a decimal, now we're approximating, okay? So just leave it exact. Let's take a look at another one. Move my little quadratic formula over here. I do not have standard form this time. I've got some rearranging to do. So I need to move the x squared and the x terms together. I'm going to go ahead and move this over to the x squared side. I like when x squared is positive. That's just my particular preference. So I have x squared minus 2x equals 0. Now I'm going to identify my a, b, and c. So my a would be 1. My b would be -2. But what about my c? I don't see a constant term here. It would be 0, exactly right. My constant term here would be 0. Okay, constant term is 0. So now I'm going to go plug this in to quadratic formula. So x equals, change the sign on b, so I would get +2 plus or minus the square root of that b value squared minus 4 times our a value times our c value all over 2 times a. And now we'll simplify. So under my root, -2 squared would be 4. Right? -2 times -2 is 4. And then I have -4 times 1 times 0. Well, all of this would just be 0 because anything times 0 is 0. So this is all just 0. So I have 4, you can think of it as +0 or -0. It doesn't matter because it's 0. 4 plus 0 or -0 would just be 4. So under my root, all that's left over is 4. And then on the bottom, 2 times 1 is 2. So let's clean this up a little bit. I have x equals 2 plus or minus the square root of 4 over 2. That's what we've got right now. Can I simplify the square root of 4? What is the square root of 4? 2, right? This is going to be 2. So what I have is x equals 2 plus or minus 2 over 2. Whole lot of 2's there. Now, I want you to think back to some of our solving with square roots problems and our solving by completing the square problems. Let's ignore the bottom of this for just a second. You guys had stuff like this before, where you had a number plus or minus a number, and you needed to simplify. Okay? So what we did in that case was split it up into 2 little problems. X equals 2 plus 2 and x equals 2 minus 2. We're going to do that same thing here. We're just also going to have this 2 on the bottom for this particular problem. So this is x equals 2 plus 2 over 2 and x equals 2 minus 2 over 2. And we'll simplify. These are all numbers that we can actually add and subtract, unlike some of our roots, so we're going to simplify. 2 plus 2 would be 4. 4 divided by 2 is 2. So I get x equals 2. And then over here, 2 minus 2 is 0. 0 divided by 2 is 0. So there are my 2 solutions for that example. Get two nice integer values there. I would like you now to try our last two examples. Give those a shot. I want you to use quadratic formula on these. There are some other strategies that you could use successfully, but I want you to practice quadratic formula. Be careful with your signs and don't try to skip steps on these. Well, it's only going to use C because it doesn't have an X attached to it. That makes it inconsistent. So this one's out of order. Even when you move this around, yeah, you have to rearrange. But the thing without an X is always your C. The thing with just X is your B. And the thing with X is always your A. Okay, let's take a look at these. The first example I asked you to try is already in standard form, so that saves us a little work. My A is 5, my B is -3, and my C is +3. I'm going to plug these values into quadratic formula, and I get x equals +3. Remember, we changed the sign on that B value for the front, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And from here, I'm going to simplify. -3 squared is 9. -4 times 5 times 3, that would be -20, -60. 9 minus 60 would give us -51. So under my root, I would have -51. And then on bottom, 2 times 5 is 10. So if I tidy this up, I have x equals 3 plus or minus the square root of -51 over 10. I want to see if I can simplify that root at all. Since I'm taking the square root of a negative number, I know for sure I'm going to get something imaginary. Anytime you have a negative inside of a square root, remember that means you've got something imaginary. And then if I try to factor 51, 3 times 17, 3 is prime, 17 is prime. I'm not going to be able to simplify the 51 any because I have no pairs here, but I do want to make sure I pull out that I. So we end up with x equals 3 plus or minus I root 51 over 10. When we did our problem sets on imaginary numbers, some people had put their i's behind the square root, and that's not necessarily wrong, but what some of you noticed is that if you're not very careful, you accidentally put your I under the root, and that is incorrect. So anytime you've got an imaginary with a square root, okay, I would like to see your I in front of that root, not behind it, because it is incredibly difficult to make sure that your I is outside of the root if it's behind the root. So throw it in front there, okay? And then this is as simplified as this one gets. I can't reduce any part of the 10 with 3 or 1 I, so we're good there, we're done. This would be these are our two solutions here. Questions on this one? Okay, now let's take a look at our next example. We don't have standard form here, so I'm gonna have to move some stuff around. I'm gonna move the 16 to the other side. If you moved this stuff over here, that's fine too. As I said earlier, general preference is to have the x squared term be positive, but you don't have to have it positive to be able to use quadratic formula. So I'm gonna show you that with this one. So we would get 0 equals, I am going to rearrange this into standard form though, -x squared plus 10x minus 16. If you moved your stuff to the other side, that's okay. We're still going to get the same final answers as long as we simplify correctly. My A value here is -1, B is 10, and C is -16. And now I'm going to plug this into quadratic formula. So x equals opposite of b, so I'll have -10 plus or minus the square root of 10 squared minus 4 times -1 times -16 all over 2 times -1. Now we simplify. 10 squared is 100. -4 times -1 times -16. Since I've got 3 negatives, it's going to be negative. And this would give me 64. 4 times 1 is 4. 4 times 16 is 64. 100 minus 64 gives me 36. So under my root, I'll have 36. And then on the bottom here, 2 times -1 is -2. So I have x equals -10 plus or minus the square root of 36 over -2. We know the square root of 36. That's just 6. So I get x equals -10 plus or minus 6 over -2. Since this has simplified down to integers that I can work with, I'm going to split it up and simplify completely. So I have x equals -10 plus 6 over -2, and x equals -10 minus 6 over -2. On top here, -10 plus 6 would be -4. -4 divided by -2 is +2. And then -10 minus 6 would be -16. -16 divided by -2 would be +8. So 8 and 2 are my solutions there. Questions for me on either of those? Okay, that's quadratic formula. I need standard form. It has to be a quadratic equation. If I've got an x cubed, you can't use quadratic formula. So standard form in a quadratic equation, I identify my a, b, and c and plug it in here. The bulk of the work again is that simplifying.